Good morning, each one of you. Thank you for joining us today. So let's start with our session. Respected head of the Department of Computer Science and Engineering, esteemed faculty members, expert speakers of the day, and all participants, a very good morning to all of you. Today we have gathered to attend the lecture on Machine Learning in Remote Sensing Applications under the Research, Innovation and Technology Lecture Series 2021, organized by Department of Computer Science and Engineering, Punjab University, Patiala. A warm welcome to all of you. Before starting today's session, I would like to introduce our expert speakers of the day. Firstly, we have Dr. Veet Kamal Tiwari. Good morning, sir.
Good morning.
Dr. Tiwari did his MSc in Geology from Ranchi University, followed by MTech in Remote Sensing and GIS from SRM University, Chennai. He did his PhD in Earth Sciences from IIT Roorkee, during which he joined Center of Glaciology at Wadia Institute of Himalayan Geology, Dehradun as a scientist. Presently, Dr. Tiwari is working as an assistant professor in Department of Civil Engineering at IIT Ropar. Dr. Tiwari has several publications, patents, and articles to his name. His work on geology of Moon produced first pieces of evidence about the recent volcanism on the far side of the Earth's moon. So I'm very pleased and honored to welcome Dr. Tiwari for today's lecture.
Thank you so much.
Thank you, sir. Thank you for joining, sir. The second speaker of the day is Dr. Sartaj Veer Singh Dhillon. Dr. Dhillon did his BTech and MTech from Punjab Technical University, followed by a PhD in Electronics and Communication Engineering from the same institute. Dr. Dhillon has been awarded a fellowship by Science and Engineering Research Board, New Delhi. He is working as a visiting researcher with Department of Civil Engineering at IIT Ropar. Dr. Dhillon has authored many SCI indexed articles, Scopus indexed book chapters, and holds many inventions to his name. He is an active member of various international and national societies. Dr. Dhillon is specialized in interfacing of electronics and communication devices and image processing tools. Dr. Dhillon, we are very much delighted to welcome you to today's event. Now, before we start, thank you, sir. Now, before we commence with our today's session, I would request our Honorable HOD, Dr. Raman Mani, to say a few words.
Respected Dr. Veet Kamal, Dr. Sartaj Veer, faculty members of the department, and participants. It's my pleasure to welcome you all at the expert talk on a very, very important subject, the machine learning in remote sensing, under the Research, Innovation, Technology lecture series started by the department. Now, the purpose of this series was that the students take too much time to find the areas of their research. Sometimes I have seen that the students take 6 to 8 months or even to 1 year, and they are not able to find the proper research area and the recent research areas to do their PhD work. So with this thought, the department started this series that when the experts they will deliver a lecture on one particular subject, the students will be aware of the various areas of the research. So I am very thankful to the experts today, Dr. Veet Kamal and Dr. Sartaj Veer, for sparing their valuable time to deliver a talk on very, very important subject. So, sir, thank you so much for joining us today.
Thanks a lot.
The area of machine learning, as you all know, that it is now applicable in each and every sphere of life. And today's lecture is that the remote sensing, machine learning in remote sensing. So you see, the application of a machine learning in remote sensing is so useful that if you want to do the urban monitoring, if you want to do the surveillance, if you want to find the patterns, so there are so many areas like in agriculture. So there are so vast application of remote sensing, machine learning in remote sensing. So I hope that at the end of this lecture, all the students, faculty members, and the researchers, they will be well versed in the various applications of machine learning in the remote sensing. And I hope that with this lecture, they will be able to save approximately 6 to 1 month of their literature review, because students keep on finding literature review and they are not able to find the proper area of research. So thank you so much for joining all the participants, and I hope that at the end of this lecture, you all will be well versed with the various applications of machine learning in remote sensing. So now, not taking much of your time, I hand over the session again to our worthy colleague and the coordinator of this expert talk, Dr. Navroj. Thank you so much.
For the starting of the session, shall we start, sir?
Yes, we can. I will start first.
Okay. Okay. Since Dr. Sartaj will join afterwards. I mean,
Yeah.
he will deliver the lecture afterwards. Okay. Fine, sir. So you may start presenting.
Yes, I am just sharing.
Fine.
Hope the presentation is visible to everyone.
Yes, it is visible, sir. I hope it is visible to all the participants as well.
Yeah. Yeah, thank you.
I think it is
Uh,
visible, sir. Yes.
Yeah, thank you very much for a nice introduction. And this is really a good initiative that when we talk about the various topics, it will be very good for students to get something new from that and start their research. So we have decided to break the presentation into two parts. I will be introducing the remote sensing, basics of the remote sensing. What is the remote sensing? Sometimes we are a bit confused and we don't know about the entire domain of the remote sensing. So I will be introducing the basics of remote sensing, and then Dr. Sartaj Veer will be explaining the machine learning algorithms and how we apply into those algorithms into the remote sensing. So without taking much time, let us start with the definition of remote sensing. And when we talk about the remote sensing, it is the not only the technology, it is both technology and science of yeah, it is both the technology and science of acquisition of information without coming into contact with any natural or man-made structures. In the remote sensing, we analyze the variation in the way Earth's surface features reflect and emit. Here I am using both the terms reflect and emit the electromagnetic radiations to derive the information on these features. So one of the best example of remote sensing can be seen from this presentation itself. I am presenting from Roper and everyone is listening from their own home, comfort of their own home or the department. So no one is in contact with me, but you all are getting the information about the this presentation, and you are also visualizing me using the video camera and your computer screen. So this is one of the example of remote sensing. So any information if we gather without coming in contact with the object, then that technology or the science behind it is known as remote sensing. And if we talk about the typical remote sensing system, this diagram highlights it very well. We have our sun, source of the energy, which is sending the energy toward the Earth's surface, and it is reflected. And when the energy is absorbed here, then these energies are also emitted by the Earth's surface. Like in thermal region, what happens is that the Earth's surface, when it is above the 0 degree Kelvin, then it emits the electromagnetic radiation through it, and those radiations are captured by the sensors which are installed at the aerial platform, satellite platform, or any other platform. And even the terrestrial platform, we take a mobile and take a photograph, then someone sees that photograph and know about the object of which we have taken the photograph. That is also a remote sensing, kind of a remote sensing, that is called terrestrial remote sensing. Then this data are recorded either in the digital form or in the pictorial form, and then which it is analyzed either visually or digitally nowadays we are most relying on the digital platform, but for the verification of the output, we have to go to visual image interpretation also. And then those information are stored in the GIS environment, and then it is given to the users. What is the source of energy for remote sensing applications? If we talk about this, then everybody would be aware of electromagnetic radiations. The sun is one of the prime source of natural electromagnetic radiations, which are coming to us in the wavelength of zero point 0.4 to zero point 0.7 micrometers, and from UV radiation to near infrared radiations, and these regions are uh, all are coming toward the surface, and then it is reflected back. In remote sensing, we also use the thermal IR and microwave data. These two are completely different. So we can divide the remote sensing into three aspects: optical remote sensing, thermal remote sensing, and microwave remote sensing. Optical remote sensing deals in the visible region. Thermal remote sensing is another category, and then microwave remote sensing deals in the another region. Now, what happens when the radiations interact with the Earth's surface? These radiations are either absorbed, transmitted, or reflected. So, some energy is absorbed by the surface, some is reflected, and some is transmitted inside the object, which is gathered, which is stored in the surface, and later on it is emitted in the form of longer radiations. So when we talk about the reflection can also be of different type. One reflection could be specular reflection, like the reflection that we see from the water bodies, or in the microwave region, when there is a tall building or any corner, edgy kind of object is there, then from those edges we see the uh, high reflection, and that is called specular reflection. And then the most ideal reflector for the Earth's feature is the diffused reflector. In diffused reflection, the incoming radiations are reflected in all the directions. So why it is important? Because if we have a satellite, and satellite is capturing the information, suppose we have a satellite here, and it is capturing the information down below, and this is the source of the this is the source of the radiation, suppose our sun. So if the object is having the specular reflection, the satellite will capture nothing. So if it has a diffuse reflection, it will capture the about the object. So most of the Earth's surface features are having diffuse reflection. Now, when we come to the source of the energy or radiation, I told you that sun is one of the prime source, and when the remote sensing system uses the sun as a source of energy, and that is when the like your optical camera, your mobile camera, or any other camera that you hold, satellite has similar camera, and when it uses the energy which is coming from the sun, then those sensors are called passive sensors, because they don't have their own source of illumination. And when the sensor itself sent the signal toward the electromagnetic radiation, and which is captured by the satellite, then those sensors are called active sensors. The radar is one of the prime example of active sensor. So now, how does the electromagnetic radiation interact with the atmosphere? In atmosphere, when the electromagnetic radiation passes through, then we see two phenomena. scattering, and absorption. So some rays are scattered. So we have three types of scattering: relay scattering, my scattering, and non-selective scattering. When you go in a foggy night and when you switch on the headlamp of your car, you will see that you will not be able to see anything because a blanket of rays will be created in front of you. That is because of the phenomena of scattering. So when the the sun rays are coming toward the surface of the earth, then also scattering happens, and that is why we can see the clouds, and same things are also recorded by the satellite. So, and another phenomena which happen is absorption. Everyone knows that because of the presence of ozone layer, we don't get the UV radiation. So, and in atmosphere we have water vapor, carbon dioxide, ozone, and many other gases. So these gases and elements tend to absorb many of the radiations which are coming from the sun. Why this is important? Because if the radiation is getting absorbed and we build a sensor which works in those wavelength, then we'll be able to not visualize anything in the earth's surface. So the radiation which passes through the atmosphere are called atmospheric windows. The wavelength which can pass through the atmosphere are called atmospheric windows. Here all the atmospheric windows are listed, and the bold ones are the prime atmospheric windows where the satellite sensors are built. Like in the visible region, you can see that 0.30 to 0.75 is the range which is most prominent in the optical region. If we build a sensor which works at the wavelength of 0.76, then we will be getting only a dark image because those radiations are not allowed by the atmosphere to pass through. And when the radiation is not coming inside the earth's surface, they cannot go outside also. So now we have talked about the absorption, scattering, transmission. So what are the radiations which reaches the sensors? So there are two type of radiations which reach the sensor. One is directly, which is reflected by the object, and second radiations which reaches the sensor are from the nearby pixels. Suppose there is a area, land surface, and some water body is also present nearby. So water has a specular reflection. So it reflects the radiation in a particular direction. So if that radiation is also mixing with the reflection of the land surface, then land surface will appear brighter than the land surface where there is no water body. So that is one addition which is added to the reflected light. Then in the atmosphere, what happens is that because of the scattering, the light rays are transmitted in every direction. So some of those light rays are also sent in the path of the sensor. So those radiations are called path radiance, and all these things are combined together, and we capture everything through the sensor. And that is why when we analyze the image, we have to do first the atmospheric correction. Here we analyze the atmospheric water content and other thing. Different models are used, and then we correct the image and subtract this path radiance from the images. Now coming to the remote sensing images. What are remote sensing images? So satellite receives the radiations which are reflected by the Earth's surface. And these radiations are nothing but the brightness value, different brightness of the ground object in different wavelength. The suppose some object may be brighter in the red region of the electromagnetic radiation, and some may be in the green wavelength. Some object reflects more the red region, and some object reflect more the green region or blue region or any other region. So the amount of reflection is captured by the sensors, and they are recorded as a digital numbers. Now, as soon as the digital numbers come, the application of computer science people comes from here, because we when we do image processing and we analyze the image, we analyze nothing but the digital numbers. They are the data points that we analyze. So this is how a image looks like, and this is the visual form of the image that we see in our computer screen, but background of that is something like this. When we see this portion here, a bridge is passing and nearby water bodies are there. So bridge is brighter and water bodies are darker. So if we see this representation in the form of data, you will see that these values are more and these values are less, 10, 12, 13, and these are 128, 130, 140, and these are the value of bridge, and these are the value of water bodies. So using different algorithms, what we have to do when we have to identify the bridge, then we have to identify these numbers from the other numbers. Now, what type of images that we have in remote sensing? We have three kinds of images primarily. First is the panchromatic image, second one is the multispectral image, and third one is the hyperspectral image. In panchromatic image, what happens that a single band of image is captured in a black and white form. So the entire electromagnetic region, that is from point 3 to point 9, we capture only one image. In multispectral, what happens that we capture multiple images in different electromagnetic region. Like for a green region, we capture one image, for blue region, we capture one image, and for uh, red region we capture another image. So we combine these three to get a colored diagram of the earth surface, and that is called multispectral. That means we have different spectral bands of the images. And hyperspectral, it is also kind of a multispectral image, but here the wavelengths are further divided into hundreds of different spectral regions. Like in multispectral, we capture one band of image from point 3 to point 4 will become one band, but in multispectral, point 31 to point 32 will be one spectral band. So here we'll have image, a single image, multiple images captured, like in hundreds of images captured for a particular region at a given time. Uh, Now, coming to the another form of sensor is passive microwave sensor. When the sensor is working in the microwave region, our Earth surface features some